Today we are going to go over imaginary numbers. What I want you guys to do is to do now 1, 2, 3, and 4. So that's going to take 2 to 5 minutes. Do those 4 questions, pause the video, and play it once you're done. So number 1, the square root of 64, well, that's asking us what times what is going to give us 64, and those both need to be the same number. That would be 8 times 8. So the square root of 64 is 8. The square root of 24, the next question, well, there's not a perfect number. 24 is not a perfect square, so a number times a number, when it's the same number, cannot equal 24. Instead, what we have been doing, get the highest perfect square that goes into 24, which is 4. So rewrite it as radical 4, then 24 divided by 4 is 6, and that is 2 radical 6. And number 3, radical negative 81. So we need a number, same thing, times another number. The same number, so the same number times itself to equal negative 81. What do you think that number needs to be? Well, you said negative 9 and negative 9. Well, negative 9 times negative 9 is positive 81. We need negative 81, so not negative 9. If you do 9 times 9, that's also positive 81. We need a negative 81. So you might say, oh, what about 9 times negative 9? That is equal to negative 81. But these aren't the same numbers, so that you can't use that. It has to be the same exact number. So in this case, what we've been doing up until now is we cannot square root a negative number. So I'm going to leave this as a question mark, and we're going to get to that in a couple minutes. So using complete sentences, explain why you cannot simplify radical negative 25 into the key words here being into a real number. So why can I not simplify radical negative 25 into a real number? What I said is because a number cannot be multiplied by itself to obtain negative 25. So because a number cannot be multiplied by itself to obtain negative 25. You could have generalized that a little bit and said a number cannot be multiplied by itself to obtain a negative number. Because if you're multiplying a number by itself, think like 10 times 10. Positive times a positive is positive. Or say it's a negative 10 times negative 10. That's a negative times a negative, which is still a positive. So you can't get a negative number when you're multiplying two of the same number together. So what we're going to do by the end of the day, I can define the imaginary unit I. I can explain why I is the square root of negative 1. I can simplify principal square roots. I can simplify I raised to any integer power. And I can simplify one-step expressions involving imaginary numbers. Let's go to the next page. So imaginary numbers. The imaginary unit I, the definition is, it is defined by I is equal to radical negative 1, and also I squared is equal to negative 1. So that's the definition of I. That's it. I is radical negative 1, and I squared is negative 1. So how we use I is we use it to simplify radicals when there's a negative inside the square root, because this denotes that we have an imaginary number. So when I look at radical negative 4, what we want to do is, I'm going to do it a little differently the first time, just to show you guys the process. But so we have radical negative 4. We're going to simplify it like we have been. The highest perfect square that goes into negative 4 is 4, but we have to factor out a radical negative 1 first, because that's now going to make this radical 4. So radical negative 1, radical 4. Radical negative 1 is I. So we would write I for radical negative 1. And then radical 4 is 2. So I times 2. It's like when we do x times 2, we don't want to write x2. You write 2x. So here we would write 2I. And that is how we would solve it. Same thing with radical negative 2. I'm going to do the same thing. Take out a radical negative 1. And then what we have left over is radical 32. Simplify radical 32. That is radical 16 times radical 2. That's the highest perfect square. I for radical negative 1. Radical 16 is 4. So that would be I times 4 times radical 2. And that would be 4I radical 2. So that's a process. I'll show you guys what I do. It's a little bit quicker. Just whenever I see a negative inside the radical, I just take out the I right away. And I'll say that's I 32. And then I do the same exact thing as what we do. It just, once you get used to seeing the negative inside the radical, you don't have to take out radical negative 1. You can just take out I. You get the same exact thing. So why is I equal to radical negative 1? Why would you think that? Take a minute and think about that. Why would I be equal to radical negative 1? Pause the video and think about that. So, because a number cannot be negative inside the square root and still be a real number, we have to denote it as imaginary so we can factor out that negative 1. Well, the square root of negative 1. So here's what I'm going to say. Because a number cannot be negative inside of a square root and still be a real number. Therefore, to denote that we don't have a real number, we take out radical negative 1, which is I. So therefore, we can factor out a radical negative 1, which we denote as which denotes the number as imaginary. And we use, instead of radical negative 1, we just write I. It's a lot easier to see that it's imaginary, like we did in the previous 2 questions. So, let's simplify the next 3. We'll simplify these next 3 radicals. So I'm not going to take out radical negative 1. I'm just going to take out I instead. So we get used to just taking out the I. So I take out the I, and that leaves us with a positive inside the radical. So radical 196. Radical 196, the highest perfect square. Actually, 196 is a perfect square. Feel free to check that in your calculator. The square root of 196 is 14. So that would be 14I. Number 2, square root of negative 192. Take out the I. That will make the inside positive. We denote this as an imaginary number. So that would be I, and then the highest perfect square that goes into 192, 64. So it'd be 64, rad 3, rad 64, rad 3. Let's continue to simplify that. That would be I times 8 times radical 3, which is 8I radical 3. I want you guys just to take a minute, pause the video, try number 3. Play it when you're done. So number 3, same process. negative 5. I'm going to take out radical negative 1, or I. That makes the 27 positive on the inside of the radical. Simplify radical 27 to radical 9, radical 3. That would be negative 5i times 3 times radical 3. Now we can multiply negative 5 and 3. You get negative 15i radical 3. So that's a little simplifying imaginary numbers, well, with a square root and negative inside the square root, called the principal square root. So let's go to the next page. So find I to the 0 first. Then find the value of the subsequent powers of I to the first and I to the second are already found, by rewriting each using factors that you know the value of already. So I want you guys to take your time on this. Take 3 to 5 minutes. Fill in all these values for the powers of I. Make sure you are rewriting using factors that you already know the value of. Remember, when we are multiplying with the same base, you add the exponents. And then, do you notice a pattern here? Explain the pattern as best as you can. I don't think anyone's going to say the same exact thing for that, but if you get it, it should be the same general idea. So go ahead, pause the video and play it. Once you're done, take your time. So I to the 0 power is anything to the 0 power. That doesn't change in imaginary numbers. It's always 1. And so anything to the 0 power, it's always 1. We know I to the first power is I to the second power is negative 1. How about I to the third power? So how did you write that using factors that we already knew? Well, I know I to the third is I squared times I to the first, we could say, or just I. So that would equal I to the third, because you add the exponents when you're multiplying. So I squared is negative 1. I to the first is I. So negative 1 times I would be negative I. So I know I to the third can simplify to negative I. And let's do that with I to the fourth. So I to the fourth, if I want to write that as factors that we already know, well, that could be I squared times I squared. I squared times I squared, you add the exponents, I to the fourth. So that would be, let's substitute what we know. Negative 1 is I squared. So negative 1 times negative 1 is 1. So I to the fourth is 1. I'm going to do a couple more so you guys can see the pattern of what we're doing. I to the fifth, writing that as factors that I know. Let's do I to the fourth. And you could choose anything. You could choose I to the second and I to the third. I'm just trying to choose the easiest numbers I want to work with. So 1 is a really easy number to work with. So I'm going to choose I to the fourth every time I can. So I to the fourth times I to the first, which is just I. So I to the fourth I know is 1. I found that down there. And then I to the first is just I. So I to the fifth is equal to 1 times I, which is I. Let's do I to the sixth. I'm going to do I to the fourth times I squared. I to the fourth is 1. I squared is negative 1. 1 times negative 1 is negative 1. And you're going to see this pattern. I'm going to show you guys the rest of this pattern. Let's just do one more. So I to the seventh would be I to the fourth times I to the third. We know I to the fourth is 1. I know I to the third is negative I, so I'm plugging in values that I know. So I to the seventh is negative I. And here I'm going to show the rest of these right now. Here are the rest of the powers, what they simplified to. Did anyone notice a pattern here? Well, I said for any I to the nth power, so we don't know what n is, if n divided by 4 has a remainder of 1, then I to the n is equal to I. Look at, that would be I to the first, I to the 5th, I to the 9th. It keeps going. Think 9 divided by 4 would be 2 1/4. That remainder there is a 1. Remainder of 1. So if you have a remainder of 1, or I guess 2 1/4, it'll also be 2.25. You can see that 0.25 is a remainder of 1/4. A remainder of 1, it'd be 1/4. So, and then if it's n divided by 4, so when you divide the exponent by 4, and you get a remainder of 2, then I to the n is equal to -1. And take a look here. Where did we have -1? We had it here, I to the 2nd, I to the 6th, and I to the 10th. If we divide, let's just do 10 divided by 4. You get 2 2/4. The remainder there is 2. And it keeps on going. So if you do n divided the power of the exponent, the exponent divided by 4, and you get a remainder of 3, then I to the n is equal to -I. You should see that right here. I to the 3rd, I to the 7th, and I to the 11th. Let's just do those division. I'll do 11 divided by 4 so I can show you guys. 11 divided by 4 would be 2 3/4. So our remainder there is 3. So whenever you divide by 4 and your remainder is 3, you simplify to -1. And finally, when you divide by 4, the power by 4, and you get no remainder. So when it's a multiple of 4, when the power is a multiple of 4, you get I to the n power is simplified to 1. So that's the best way to explain the pattern. You might have said something very similar, and it could be correct. But I would make sure you guys write this part down. So let's go to the next page. Here is a little easy way of remembering the powers of I. So I to the 1st is I, or when you divide the power by 4. When you divide the power by 4 and the remainder is 1, it's equal to I. I squared is equal to -1. Then I to the 3rd is equal to -I. I to the 4th is 1. I to the 5th is I. I to the 6th is -1. I to the 7th is -I. I to the 8th is 1. And it keeps on going in circles. I to the 9th. I to the 10th. I to the 11th. I to the 12th. I to the 13th. I to the 14th. I to the 15th. I to the 16th. So it keeps on going in that circular pattern. So, medium funny joke of the class. Why is I the most annoying opponent to lose to? Well, why would he be the most... Well, let's think about it. All he says is, I won. I won. I won. I won. I won. I won. No one likes a bragger. I mean, come on. Oh. So, completely simplify the following powers of I to the 21st. So I'm just going to take the exponent. I'm going to use what we have been doing. I'm going to divide it by 4. And what do you get? You should get 5.25. That 0.25 shows us it's 1/4. So we have a remainder of 1. So this would just be I. About I to the 30th, take the exponent, divide it by 4. You would get 7.5. I also like, instead of looking at just the remainder, this is also kind of looking at the remainder, but think about quarters. So quarters, quarters are 25 cents, 50 cents, 75 cents, and then a perfect dollar. So how many quarters do we have left? We have 2 quarters, so that would be I to the 2nd, which is -1. That's just another way of thinking about it. That's actually how I think about it. And then I to the 39th, take 39, the exponent, divide it by 4. You get 9.75. What's the remainder, or how many quarters do we have? Well, it's I to the 3rd, which is -I. And the last one, take the exponent, 184, divided by 4. What do you get? You get 46. There's no remainder. So this would be I to the 0 power, or I guess you can think about it as I to the 4th. It doesn't matter. They both just equal 1. So that's how we want to simplify powers of I. I want you guys just to take the next 2 to 5 minutes, do the checkpoint A through K, and just pause the video and play it once you're done. Here are the answers to the checkpoint. Make sure you check each of them. I just took each exponent, divided by 4, and simplified it using what the remainder was, or you can think about how many quarters there are, and that simplifies it for you. So that's A through K. Once you're done checking that, we're going to the next page. Doing a little bit of operations with imaginary numbers. Find the sum. So we know we're going to be adding. So find the sum of 7i squared and 15i to the 15th. So what you want to do before you go adding them is simplify that I as much as possible. So here we have 7i squared. I know the I squared is really -1, so that'll be 7 times -1 plus 15 I to the 15th. Take that exponent of 15 and divide it by 4. You would get 3.75. Because you got 0.75, we have a remainder of 3. Think 3 quarters. So that's really I to the 3rd. So I to the 15th is simplified to I to the 3rd, which is -I. So I'll plug in -I in for I to the 15th. And I'll simplify that. So that would be -7. And then 15 times -I would be -15i. And that would be our simplified answer. So always simplify the powers of the I before you add, multiply, divide, or subtract anything. Number 2 says find the difference, so we're subtracting this time, of 7i squared and 15i to the 15th. We already simplified these already, so I know 7i squared is going to be 7 times -1, and 15i to the 15th will be 15 times -I. And 7 times -1 is -7. -15 times -I, in this case, would be plus 15i. And that would be our answer for that. Product. So simplify the product. That would be 7i squared times 15i to the 15th. You can simplify first still, or you can just multiply. For multiplying, either way, it depends. Either way can be easier. So I'll simplify first. So that would be, we know 7i squared is 7 times -1 times 15 times -I. We would get -7 times -15i. So -7 times -15 would be positive 105i. And you could have also done it just by multiplying 7 and 15 and then adding the exponents on the I to get I to the 17th. I don't know if you guys did that watching this, but you would still get 105i. And simplify I to the 25th to the 47th. I'm going to, just to show you guys a different way of doing it, I'm not going to simplify the I to the 25th first, and we'll see what happens. So I to the 25th to the 47th, we want to do what when we have power to a power? We multiply the exponent, so that'd be I to the 25th times 47. And 25 times 47 would be 1,175. That's a large exponent, but let's just simplify it. Divide it by 4, see how many quarters we have remaining. That would be 293.75. So that just becomes I to the 3rd, which is -I. So that large exponent just simplifies to -I. But say you guys want to do the other way, and I'll show you guys the other way also that we have been doing. Simplify I to the 25th first. So that would be, do 25 divided by 4. You would get 6.25. So 0.25 means we have a remainder of 1. So that would simplify to just plain old I. So that would be I to the 47th. And now you got to do 47 divided by 4. You would get 11.75. Our remainder there is 0.75. So it's a remainder of 3. Think 3/4. So that would be negative I. You get the same thing. Usually simplifying the numbers first is a little bit easier. But in this case, I think they're both pretty good. Maybe even not simplifying first was easier. So the success criteria is after this, the classwork, and there's also homework. That's it.